Good morning, this is the Light School Nushara campus. It's chemistry class for 9th. Our today's topic is shielding effect. What's shielding effect? So shielding effect is the reduced force of nuclear attraction on valence electrons due to inner electrons is called as shielding effect. What does it mean? Look at the diagram which I'm about to make. Here we are having nucleus in the center. Here is the first orbit, K shell. Then second shell being, if you remember, that is L shell. Third shell is M shell. So we do know that K shell has 2 electrons in it, L shell has 8 electrons in it. 2, 3, 4, 5, 6, 7, 8, and then M shell have 18 electrons in it, right? So what actually happens? We do know that nucleus has protons, whereas these shells have electrons. If there are 18 protons in an atom, there would be 18 electrons in the same neutral atom, right? This means that nucleus attracts all of the electrons. So nucleus is having an attractive force over all these shells. For what purpose? To attract these electrons towards its center. But what happens? The case which we usually observe, that is that the first energy shell faces more nuclear attraction. Why? Because this shell is very close to the nucleus. The more it is close, the more it will observe nuclear attractive force. Whereas the second shell will exert less force as compared to the first shell. There are now 2 main cases. What's that? These cases, or case number 1 is the distance. The more there is distance, the less will be the nuclear force, right? And case number 2 is the repulsion forces. Which repulsion forces? We do know that this is a positive charge, it's a negative charge, so they do have attraction with each other. But what about the second shell and the nucleus? So nucleus will try to attract the second shell also because it's having more protons. But this first shell will not allow these electrons to come closer to the nucleus. Why? That's because if this electron is negative, these electrons are also negative, and we do know that negative always repel each other. It will repel it and this will repel it. Right? So here is a repulsion forces between these electrons and then between these electrons, also among these electrons. So they will try to repel each other. Because of this repulsion power, the nuclear attractive forces are reduced, and this reduction in the nuclear attractive forces is called shielding effect. And if someone asks you how or what causes this shielding effect, so a simple answer is that the inner electrons present in the atom exerts a shielding effect over the valence electrons, right? So this means that the valence shell always occupies or always gets less nuclear attraction as compared to the inner shells. Just take the example of lithium and sodium. Lithium is in group period 2, whereas sodium is in period 3. Both of them are present in group 1. Group 1 means it has one electron in its outermost shell. Group 1 means sodium is also having one electron in its outermost shell. Period 2 means there are altogether 2 shells in lithium atom, whereas period 3 means there are altogether 3 shells in sodium atom, right? Okay, so the electronic configuration, or lithium has atomic number 3, sodium has atomic number 11. Let's draw their electronic configuration. That's school, public. So this is 1, it's 2 electrons over here, 1 electron here. So this means that lithium's first shell will have 2 electrons, whereas its second shell will have 1 electron. Coming to our sodium, 11. So school, public, school. This is 1, 2, 3. This P is second, comma. Okay, 2 electrons here, 2 electrons here, 6 electrons, 6, 7, 8, 9, 10, and 11, 1 electron here. Altogether, 1, 2, 3. 3 shells are present. In first shell, there are 2 electrons. This is nucleus. In the second shell, there are 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8 electrons, whereas in the third shell, there is only 1 electron, right? Now look here. The shielding effect in the case of sodium is strong. Why? Because it's having 2 inner shells. And these inner electrons will reduce the force of nucleus over the valence shell, or to over the valence electron, whereas in case of lithium, there is only 1 inner shell, right? So its effect on the valence shell will not be that much as this is in case of sodium. So we can say that by coming from top to bottom in a group, the number of shells increases. As the number of inner shells increases, their shielding effect also increases. Why? Because the more there are inner shells, the more would be electrons here, and the more there are electrons, the more will they reduce the nuclear attractive force over valence electrons, right? But what's the case in moving from left to right in a period? Like here, in the period, that's take an example of second period, the same lithium one. So second period means this is lithium, here there is beryllium, here is boron, then carbon, right? Second period means that there would be 2 shells. Right? And as this is group 1, group 2, group 3, group 4, so what will happen that in its valence electron valence shell there would be only 1 electron, in its valence shell there would be 2 electrons, here will be 3 electrons, here will be 4 electrons, and so on. As a result, the size of the atom would decrease because there will be more nuclear attraction. But what happens to a shielding effect in the period? In period, the shielding effect remains constant. This means the shielding effect do not change at all. Why doesn't the shielding effect change? The shielding effect doesn't change because the amount of shells or the quantity of shells, inner shells, remains same, which do not reduces the nuclear attractive force over the valence shell electrons, right? So we can say that while moving from top to bottom, the shielding effect increases because of increasing number of shells, whereas from left to right in a period, the shielding effect remains constant because of same shells in the period. So that was, I think, enough for today. What you have to do, you have to solve all the questions given in your Google Classroom as a homework. Be ready for your detention examination. This topic would be involved there. If there is any problem, you may please ask. Don't hesitate in asking anything. And I will provide another link as well, which will help you in understanding more nicely. So thank you very much. Take care. Bye bye. Have a good day.